Hi everyone, I'm Kirtana from group number 501. Today I'm going to present our milestone 1 video for our project lexChat. So, do you know we have almost about 365 legal articles in our country? But is it possible for us to know the right one instantly? No, right? So, here comes the role of lexChat. lexChat is a legal question and answer chatbot which takes in all the any kind of legal queries in our Indian legal system and gives answers accordingly. So let's know the scope of our project. Our focus is on building a chatbot, which is multi-conversational. It is made up of RAG model and especially deals with all kind of Indian legal acts and sections. Currently, if we want to know anything about the act or section or any problem we have faced and you want to know it comes under which category of the act or section, then either we have to search the whole long legal document or consult an expert, which is very time taking and frustrating. So, to reduce the time of the entire process, we have come up with this idea. It would be mainly useful for law students as they can spend more time on focusing on analysis rather than wasting their time in searching. And it would be helpful for advocates. They can reduce the case preparation time, and common citizens like us, we majorly know few of the legal terms and our rights and obligations. So it will help us in knowing more about our rights. Understanding of the paper. Our research paper was lexRAG, which is the first benchmark for multi-turn legal question and answer with RAG system. The data sets which they used were the Chinese ones, about 17,000 plus legal articles and 1,000 expert dialogues. It is made up of RAG. RAG means retrieval augment generator. The retriever is like a search engine. It goes through the whole database and searches the exact word with the context which is given to the generator. The generator is the main AI model which converts the content into human readable text. Next comes the main feature, which is the multi-turn conversation. If you ask a question, and again, when you ask the follow-up question, generally the follow-up question is taken as a isolated question. But here, as it is the RAG system, it understands the context properly. It stores the conversational history, and according to that, it gives the answers. They also have a toolkit which includes the retriever models, generator models, and evaluation. For evaluation, instead of manually giving scores to each answer by the experts, they have used an LLM. So it is called LLM as judge. Next comes the business problem address. So it is very complex for people like us to know the legal terminology and all. And it is very time consuming for manual search. For example, we want to find any clause, then we have to go through the whole long 100 pages legal document or else consult an expert, that is a lawyer. And sometimes for the lawyers also, it becomes difficult for them to read the whole long book. So they can use lexChat here, which in turn increases the case preparation time. So lexChat reduces the case preparation time. And during this process, sometimes they miss the critical clauses, which can resulting wrong output of the case. And there is very lower legal literacy in our country. So after reading the research paper, we have come up with a new research idea. We will be developing this chatbot on the Indian legal system rather than the Chinese one. This would also be having the advanced retrieval and generation methods and also an evaluation metrics. So we would try to compare the RAG and the lexRAG model, and we would compare the answers of both of them by giving it to a accuracy matrix, and we would also have the main feature that is multi-turn conversation and multilingual Indian chatbot so that it reaches more people. Firstly, we will build a web application and later, if possible, we will try to build a mobile. So next is the tech stack. On front end, we are using React.js as it is more responsive and interactive. For backend, we are using Python with fast API for AI model processing. And in MongoDB, we would be storing the user details, conversational history, and Express and Node for API endpoints. So in retriever, as to convert the text into numerical values, we would be using embedding model. Here we might be using all mini LM L6D2 for sentence transformation, and this would be stored in the vector database so that the retriever can know the meaning and extract the section instead of just knowing the word, which would be stored in FAISS or Chroma DB. Next, the retriever gives the content to the generator. This is the main AI model. So we would be using Llama or Mistral from Hugging Face. And Lantern is like a project manager which helps in coordinating the data flow within the pipeline. And the models which we are using is Mistral or Llama or GPT. The data set is structured Indian acts and sections and the Constitution of India. So this is the architecture diagram of the project. First, the user comes, he or she completes the authentication, that is the login or sign up process. Then they would be seeing a lexRag model chatbot interface where they can give the user input. The user input is nothing but the legal query, which is sent to the post request. So we have two post requests, lexRag and normal rag. As told earlier, we would be doing comparison between the rag and the lexRag. So the user input would be given to the lexRag model, which would be running locally in Olama. This gives the response, and at the same time, it is given to the another endpoint slash rag, which is the RAG model, which is called from Hugging Face API, and it gives the response. Now, both the responses are given to the LLM as just evaluator, which takes point-wise scoring, reference answers, and bird score. And this will give the comparison in the another dashboard. Response of the lexRag and the user details are stored in the MongoDB, and this response is also showed in the chat interface. So this is the architecture diagram of lexRag. We have the data layer which contains large data corpus of legal articles, legal books, and cases. Here we are using Indian legal system datasets. And the conversation is nothing but the user input or the query. First is the processor. Last query is the latest query given by the user. Full context, it understands using the conversational history. Full queries means it combines all the initial queries and then tries to process. And sometimes if the query is not clear, it will try to rewrite it. Next comes a retriever. We have lexical matching model. Lexical matching model is the traditional one which searches word by words exactly. It doesn't it is not concerned about the meaning. Whereas embedding models are advanced ones. That is the text which we have converted into numerical vectors. It search in that way so that it does not only matches the word but also relates to the meaning of it. Next comes a generator. To generate the human-like answer, we can use closed source LLMs like GPT or open source ones like Mistral or Llama. Then this is given to the evaluator. We have retriever evaluator, which tells how good the retrieving process took place. We will be using NDCG, MRR, recall, etc. We have generational evaluator, which tells how accurately the generation has taken place. That is the logic, is it the correct logical answer or not? We have ROG, BLEU, BERT score, and lastly, LLM as judge. It gives point-wise scoring, that is, it gives scoring to each individual answer. Multi-dimensional means it checks if the answer is complete, accurate, and clarity is present or not. Chain of thought, it checks whether the answer given is logical. And lastly, it checks with the reference answer. So the expected output is a fully functional multi-turn chatbot that takes in legal queries and gives answer like human-like language. It generates accurate AI-based explanations with a good web interface. Thank you.